You go to sleep on an ordinary night. The world is the same as it always has been. Somewhere beyond your window, beyond the cities and the highways and the fields, the ocean is doing what it has always done. Breathing, rising, falling, covering 71% of the surface of this planet in a shifting skin of salt water 3 kilometers deep on average, and nearly 11 kilometers deep at its lowest point. A trench so dark and so cold that humans have explored it less than the surface of the moon. And then you wake up. And it is gone. Not drained, not evaporated, not frozen. Gone. In the way that only impossible things can be gone. As if someone reached down into the architecture of the planet and simply removed it. Every ocean, every sea, every connected body of salt water on Earth. The Atlantic, the Pacific, the Indian, the Arctic, the Southern. Vanished between one breath and the next. Between the moment you closed your eyes and the moment you opened them again. You do not know yet. You are still in bed. But outside, the world has already begun to end. The first thing that happens is silence. Not the comfortable silence of a quiet morning. Something deeper. Something wrong. The ocean generates a constant low-frequency hum, a sound so omnipresent that no living human has ever existed without it. Scientists at the Scripps Institution of Oceanography have measured this background acoustic signature of the sea and found that it permeates the atmosphere at frequencies below human hearing. A subsonic pulse that the entire planet has carried since the first oceans formed 3.8 billion years ago. That sound is gone now. And in its absence, the atmosphere itself feels different, thinner somehow, and very still. Then the pressure changes. The ocean is not just water. It is weight. The combined mass of all the world's oceans is roughly 1.4 times 10 to the power of 21 kilograms. 1.4 billion tons of water pressing down on the ocean floor with tremendous force. Remove that weight overnight, and the oceanic crust, the thin, dense rock that formed the floor of the sea, will begin to rebound. Geologists call this process isostatic rebound. It is the same process that has been slowly lifting Scandinavia upward ever since the glaciers of the last ice age melted away. But those glaciers took thousands of years to melt. The oceans disappeared in a single night. The rebound is instantaneous by geological standards, and it is violent. Within hours of the ocean's disappearance, the newly exposed oceanic crust begins to crack and heave. Faults that have been locked in place by the pressure of kilometers of seawater suddenly release. Earthquakes erupt across the former ocean floors. Not isolated tremors, but a continuous global seismic event unlike anything in recorded history. The Mid-Atlantic Ridge, the longest mountain range on Earth at 65,000 kilometers, begins to tear open. Magma that was held in check by the crushing weight of the deep ocean surges upward through the cracks. Volcanoes. Thousands of them, simultaneously, along every oceanic ridge on the planet. The sky above the former ocean floors turns orange and black. You still do not know. You are making coffee. The news is on. The news anchors are not yet speaking, because the news anchors do not yet know either. It takes time for information to travel. It takes time for the enormity of something to become language. But the satellite images are already coming in. and what they show is impossible to process. The ocean floor is exposed, all of it. For the first time in 3.8 billion years, the abyssal plains, those vast, flat, almost featureless expanses of sediment at the bottom of the deep sea, are open to the sky. The continental shelves, those gently sloping underwater extensions of the continents that reach out from the coastlines for hundreds of kilometers before dropping into the deep, now stand exposed as enormous new plains of wet, dark sediment, stretching further than the eye can see. The former coastlines of the world now sit hundreds of meters above vast new lowlands. Cities that were once beach towns, Miami, Mumbai, Sydney, Lagos, now look out over an exposed seabed that extends to a new horizon of bare, dripping rock and sediment. And the smell. This is the part that no simulation could prepare you for. The exposed ocean floor carries the accumulated biological material of billions of years of marine life. Every creature that ever died in the sea and sank to the bottom, every layer of sediment rich with decomposing organic matter, the salt, the sulfur, the methane trapped in ancient seafloor deposits now releasing freely into the atmosphere. Scientists who have studied seafloor sediment cores, researchers like those at the Hole Oceanographic Institution, describe the deep ocean sediment as one of the largest carbon and methane reservoirs on the planet. That reservoir is now open. The smell reaches coastal cities within hours. It is unlike anything in human experience, a vast, sulfurous, biological exhalation from the deep history of life on Earth. People evacuate inland, not because anyone has told them to, because the instinct to move away from something that wrong is older than language. Now, let us talk about the atmosphere. The ocean and the atmosphere are not separate systems. They are one system, divided by a surface. The ocean absorbs approximately 25% of all carbon dioxide that humans emit into the atmosphere each year, according to research published by the Global Carbon Project. It absorbs roughly 90% of the excess heat generated by climate change, according to the Intergovernmental Panel on Climate Change. It produces somewhere between 50 and 80% of the oxygen in Earth's atmosphere, not from trees, but from phytoplankton, those microscopic marine organisms that photosynthesize in the sunlit upper layers of the sea. All of that is gone now. The carbon cycle breaks immediately. Without the ocean acting as a carbon sink, carbon dioxide levels in the atmosphere begin to rise unchecked. Without phytoplankton producing oxygen, the atmospheric oxygen supply begins a slow decline. Not fast enough to suffocate anyone today, or this week, or this month, but the trajectory is clear, and it does not bend back. The water cycle breaks next. Rain comes from the ocean. Not directly, not in the simple sense that rain falls on the sea, but the ocean is the engine of evaporation that drives the entire global water cycle. Roughly 86% of all atmospheric water vapor comes from ocean evaporation, according to data from the National Oceanic and Atmospheric Administration. Without the ocean, the hydrological cycle, the endless movement of water from sea to sky to land and back, simply stops. Not immediately. There is still water vapor in the atmosphere. There are still clouds. There are still rivers fed by glaciers and snowpack. But the source has been removed. The rivers will run, and they will not be replenished. Within weeks, rainfall across the planet drops catastrophically. Within months, rivers begin to fall. Within years, without a functioning water cycle, most of the planet's land surface becomes desert. But we are getting ahead of ourselves. We are still in the first morning. On that first morning, the immediate problem is not the atmosphere. The immediate problem is food. 97.5% of all water on Earth is salt water. Most of the remaining 2.5% is locked in ice caps and glaciers. The amount of fresh, liquid water accessible to humans in rivers, lakes, and groundwater represents less than 1% of all water on Earth. And the systems that replenish that fresh water, the rain, the snowpack, the glacial melt, all depend ultimately on the ocean. But beyond water, there is protein. The ocean provides approximately 17% of the global animal protein supply, according to the Food and Agriculture Organization of the United Nations. For more than 3 billion people, nearly half the human population, seafood is the primary source of animal protein. For coastal nations like Japan, Iceland, Bangladesh, and the Philippines, the percentage is far higher. Those food systems do not disappear gradually. They disappear overnight, at the same moment the ocean does. 3 billion people wake up on the first morning of a world without oceans to find that their primary food source no longer exists. By midday, global food commodity markets have ceased to function, not because of panic, though there is panic, but because the commodity itself is gone. You cannot trade a fish that does not exist. Now, let us go to the coast. If you live within 100 kilometers of what was formerly a coastline, and roughly 40% of the human population does, you are standing at the edge of something that has no name yet. The former shore drops away into a vast, exposed continental shelf stretching to the horizon. The sediment is still wet. In places, it glistens. In places, it moves as deep-sea creatures that survive the disappearance for a few minutes longer writhe in the exposed air. The continental shelves are not flat. They are varied. Canyons and ridges and ancient river valleys that were flooded when sea levels rose at the end of the last ice age. Standing at the former shore, you can see for the first time the submerged canyons that were cut by rivers 10,000 years ago when sea levels were 100 meters lower. You can see the remnants of coastlines that existed when the first anatomically modern humans were walking out of Africa. You are looking at deep time made visible. And then, the earthquakes reach you. The seismic wave from the oceanic crust rebound arrives at the continental margins, the zones where the thick continental crust meets the thin oceanic crust, and triggers secondary faults. Cities near former coastlines experience significant tremors. In some places, the ground liquefies. Buildings that were engineered to withstand coastal storm surge were not engineered to withstand the sudden removal of thousands of kilometers of lateral water pressure. The first 24 hours are chaos, but the second week is worse. Without rain, crops in rain-dependent agricultural regions begin to fail. The bread baskets of the world, the American Midwest, the North China Plain, the Indo-Gangetic Plain of South Asia receive rainfall that is almost entirely dependent on oceanic evaporation traveling inland via weather systems. Those weather systems are weakening. Without the temperature gradient between ocean and land that drives atmospheric circulation, the jet streams weaken. Weather patterns stall. High-pressure systems sit motionless over agricultural regions for days, then weeks. The wind itself changes. The ocean drives the global atmospheric circulation system. The trade winds, the westerlies, the polar easterlies, all of these are products of the temperature difference between the warm tropics and the cold poles, mediated by the ocean's enormous heat capacity. Without the ocean, those temperature gradients change rapidly. The winds do not stop, but they become erratic, unpredictable, driven now by land surface temperature differences alone, which are far more volatile than the slow, stable thermal mass of the sea. Dust storms begin. The exposed ocean floor, trillions of tons of fine sediment now drying in the sun and the wind, becomes the largest dust source in the history of the planet. Within weeks of the ocean's disappearance, vast dust storms begin rolling off the exposed seabed. The Sahara Desert, by comparison, generates roughly 2 billion tons of dust per year. The exposed ocean floor would generate orders of magnitude more. The dust darkens the sky. It buries coastlines. It travels thousands of kilometers inland, coating crops, clogging machinery, filling rivers. A new geological epoch begins. Not gradually, overnight. And yet, humanity does not immediately collapse. This is important, and it is true.
Human beings are, above everything else, adaptive. The psychologist Abraham Maslow identified the hierarchy of survival needs: physiological, safety, social, and history has demonstrated repeatedly that humans reorganize around those needs with extraordinary speed and creativity when survival is genuinely at stake. Fresh water still exists. Glaciers in Greenland and Antarctica and the high mountain ranges still hold vast reserves. Groundwater aquifers that took thousands of years to fill have not yet been depleted. Greenhouse agriculture, hydroponic farming, and water recycling technologies, already in use in places like the Netherlands, Israel, and Singapore, become the templates for emergency global food production.
The former ocean floor, despite the chaos and the earthquakes and the smell, is also geologically extraordinary. The oceanic crust is rich in minerals. The hydrothermal vent systems along the mid-ocean ridges, now exposed, represent concentrations of metal ores that dwarf anything available on the continental surface. Within months, the first engineers are surveying the exposed abyssal plains. Humanity moves inland, away from the chaos of the former shores, toward the high ground, toward the rivers while they still run, toward each other, in the way that people always move toward each other when the alternative is facing the impossible alone.
Cities reorganize. Governments that had been paralyzed by the scale of the catastrophe begin slowly to function again, not as they were, but as something new. The political borders that were drawn around access to coastlines and shipping lanes and fishing rights are suddenly meaningless. A new set of resource pressures, fresh water, arable land, mineral access, reshapes the map of human civilization in real time. There is loss that cannot be measured.
The ocean is not just a resource. It is not just a food source or a shipping lane or a carbon sink. The ocean is the origin of life on this planet. The first self-replicating molecules appeared in the ancient sea. Every living thing on Earth, every bacterium, every plant, every animal, every human being is descended from organisms that evolved in salt water. The chemistry of your blood, the salt concentration of your tears, the ratio of minerals in your cells, all of it reflects the composition of the ancient ocean in which your most distant ancestors lived. The ocean is not something outside of you. It is something you carry inside you. And now, it is gone. The world that remains is not a dead world. Life is remarkably persistent. The terrestrial ecosystems, the forests, the grasslands, the soil microbiomes survive. They are stressed, they are changing, but they survive. Humans survive. The story is not over. But it is a different story than the one that began 3.8 billion years ago, when the first rain fell on the cooling rock of a young planet and gathered in the low places and became the sea. Tonight, if you go outside and look at the horizon, if you live near enough to the coast to hear it, to smell it, to feel the moisture in the air that comes off the water, listen for a moment. The ocean has been breathing for nearly 4 billion years. It was here before the first fish, before the first flower, before the first footprint in the dirt. It does not need you. But you, in every cell of your body, in every drop of water you have ever drunk, in every breath of oxygen produced by a phytoplankton you will never see, you need it.
And that's today's hypothesis. If you enjoyed this journey into the impossible, hit subscribe and join the Stickman Hypothesis universe. See you in the next What If?